Says, sorry, number 6. It says 49. Stop the tapping, please. Z squared minus 16. What do you notice when you look at that? What do you notice? They are squares. They're perfect squares. Sorry, I'm going crazy with this apparently.
What's the difference between squares and perfect
Integers.
squares?
Integers. That's the difference. So 49 is what squared?
7.
49 is 7 squared, exactly. So, if I can get this done here, there we go. So this is 7z squared minus what squared? 4 squared. So you know this is, what pattern is this? What is this called? Difference of squared, mid-DOS, whatever you want to call it. So it's going to be 7z plus 4 times 7z minus 4. Could you reverse the order of those two things? Could you put the 7z minus 4 first? Absolutely, yes. But you need to remember that if you have q squared minus r squared, what does that equal? Q plus r times q minus r. Exactly. This is the difference of squares. Difference of squares. Okay, another one. Who's got another one that we should? So when you're breaking this apart, you're trying to break it apart into two binomials multiplied together. What do you know about the first two? Can someone tell me what you generally know about the first two? What do they have to multiply together to be? 6t squared, right? What about these two?
77.
Negative 77u squared, right? So in terms of the 6t squared, what two are good candidates? What do you want to try, Nate?
2 and 3.
Yeah, so how about we try 3t and 2t? And what about 77? What's a good candidate?
11 and 7.
Maybe 11 and 7. Now it needs to be negative 77, right? So what do we want to do? How about negative 11 and 7, like this? So what do we have? We have to test this to see if it's correct. We don't know automatically if it's correct. How do we test this? What do we have to do?
Just put U's at the end.
Oh, and there's U's. Thank you. Thank you very much. There's U. There's U's. They're U's. So it's 7u times 2t minus 11u. We're not sure if this is correct. We know that the first term is going to be, is 6t squared going to be there?
Yep.
Yes. Is negative 77u squared going to be there?
Yep.
But we don't know if it's negative 19tu is going to be there. So how do we test that? Yeah, well, we just multiply it out. We distribute, yeah. So what do we end up? We do end up with 6t squared, and then you end up with negative 33tu plus 14tu minus 77u squared. Well, we have that first and last. Great. But what do we end up with in the middle? Negative what? What's 33? What's 14 minus 33? Ah, you can do it. What's 14?
19.
Negative what?
19.
Negative 19tu. Is that almost what we want?
Yeah.
What's the only thing that's wrong? The sign. It's negative 19. What do we want it to be? Positive. So what should we change then? So this is almost what we want.
Change the sign.
Yeah, so it's going to be 3t what? Minus 7u, 2t plus 11u. If we do that, what happens? You end up with 6t squared plus 33tu minus 14tu minus what? 77u squared. What do we end up with? 19tu minus, and is that what we want? Yeah. So again, it will get a little bit harder, but you get your answer at the end. You need to keep track of what you test. If you don't keep track of what you test, what's the primary risk you run? You end up doing the same thing over and over again, and then you think it's prime because you didn't test everything because you just, in fact, tested not all of the things. The other thing that you should notice, what's the first thing you notice about this that tells you this is going to be a little harder than some of the other ones?
Coefficient of the first.
The leading coefficient, exactly. The 6. When the leading, you like it when the leading coefficient is 1. You love it. Or 0, yeah, it's gone, yay. But if it's 1, the only thing that multiplies out is 1 times 1. So you have x and x or u and u. But when it's not, there's more to test. The process holds. There's just more to test. But when you see this, what do you see? Is it a difference? This is the sum of what? Of what? I'll rewrite it for you. It's the sum of what? Sum of squares. Now, in this section, or I don't know, a couple of pages back, is there a sum of squares? Is there a sum of squares formula? I see difference of squares, perfect square triangle, difference of cubes, and sum of cubes. Is there a sum of squares formula? No. So if sum of squares, what are you going to call this? Prime.
Oh.
Yeah.
Seriously?
Yeah, if it was 9r squared minus 100, that's totally different. What would that be? 3r plus 10 times 3r minus 10. Completely different because what's, minus and plus. Totally different. Yes, please? You know, like, I don't know, 282, right? What can you pull out first? Let's say 2 and then 141, right? Can you go any further with 2? No, so you stop. It's the same thing here. You can't go any further than this right there. There's nowhere else to go. You have prime factor, you have a prime factor. There's nothing to pull out. The greatest common factor is 1. If the GCF is 1, sometimes it's hard to see that.
Yeah.
It just takes more practice. Okay, other ones. No one got any higher? Yeah, Nate, what'd you get?
I want 1 over 3.
3?
I said 1 over
3p to the 4th minus 3p. What's your question about this one?
3.
I need a specific question. I'm not going to do it. You need to. Someone can help me. Tell me what I should do. You're supposed to factor this, right? Can someone give me a first step? Kelly.
Take out 3p in the second.
Yeah, 3p squared. What are you left with, Kelly? P.
To the second.
Yep. Minus.
P.
Yep. Minus 30. Now, are you done?
No.
No, you're not. Why aren't you done, Alyssa? Yeah, you have to factor. This isn't factored. Can you factor that?
Yeah, but how can you tell if it's factored? I don't understand.
Okay.
That was my question.
Here's the deal. You okay, kids. This is how I'll answer the question for you. What's nice about this one, Rachel?
There's P's.
Okay, that's true. But if inside the red, what's nice about it? The leading coefficient is 1. So what is the system for factoring things where the trinomials where the leading coefficient is 1? You're looking for two numbers that multiply together to get, but add together to get -1. Are there two such numbers? How about 5 and -6? Do they multiply together to get -30? Yes. Do they add together to get -1? Yes. So what does this factor into? Well, the 3p squared is still there, but what do you now have? P plus 5 times. Now you're done. You are now done because can you factor these things any further? No. You are done because those are all prime. If you say, I'm checking now, circle your answer so I can find it. Yes. So on this one, what do you see? Do you factor? I see 2 squares. What is 625?
25 squared.
Yeah. This is 25 squared. And what is x to the 4th? X squared squared. So what does this factor into?
25
Okay, kids,
minus x
certain things you need to recognize. 625 is 5 times 5 times 5 times 5. Okay? So do you understand how we got to here? Are we okay with that?
Yeah.
Yeah? So what do you see? I see the difference of... Yeah, what are these? These are squares, right? And I see the difference of them. So what does that tell us? This equals 25 plus x squared times 25. Are we done? No, we're not. Which one can we still factor? 25 minus x squared. Because this right here is this is the sum of squares. Can we factor sum of squares? No, we're done. But what is this one? This is the difference of squares. Can we do that? Yeah, we just did. So it's going to be 25 plus x squared times what? 5 plus x times 5 minus x. Are we done now? This is where you're done. This is where you're done. When you looked at 58, what was the first thing you noticed that you knew was going to make it a little bit more work than average?
The 18.
The 18. That's the thing that makes it a little harder, but it's just a matter of guessing and checking and guessing well, and eventually does one thing work? Yeah, it does. What does it come out to be? Bless you. What does it come out to be? 9p minus, what, 5r times 2p plus 7r. Yep. Good. Excellent. So if you do this out, does it check? Yeah. You started by, what's two numbers that need to multiply together to get 18, and then you need two other numbers that multiply together to get -35. Bless you. Now, the second one, this one's a little tricky, right? Because what's the greatest common factor of all 4 terms? What's the GCF of all 4 terms? Do they have any common factors? So what is the common factor? 1. So there's nothing you can factor out of all of these to make something go away. So at this point you need to be able to recognize you will get to the point where you can recognize you should kind of take a look at this right here and say to yourself, what is that? I gave some people a hint which kind of put you in the right direction. It is hard to see. I'm not saying it's easy to see. It is hard to see. This right here does factor to something. This factors into x minus y times what? X minus y. What's along for the ride? The minus 4 just comes down, right? When you hold on, let's finish it, and then you can ask your question. How do you know this works? What's x times x, Catherine? Katie, sorry. X squared. Then you have x times that, you get negative xy, and y squared. How many negative xy's do you have? 2 of them. So does that check?
Yeah, but what's the step in between those two? Like
to go from there to there?
Yeah, I don't know what the step is.
It is knowing that x minus y squared is equal to x squared minus 2xy plus y squared. That's the step. Correct, you do. Or you need to recognize it enough to realize there's something there that's like x minus y times something and testing one of them. What did we do on this one? Did you just know the answer on this one right here?
No, but that one I feel like...
Hold on. Answer the question. Did you just automatically know what numbers multiply properly to get the additive sums proper? No. Did you test something first that didn't work?
Yeah.
Did you test something first that didn't work?
I didn't work on that problem, but I
Okay, hold on. I'll ask the rest of the people. How many things did you check before you came across the right one? Once or twice, right? You know, it's nice when it pops up. It's the same thing down here. How do you know? You need to maybe not recognize exactly that it's x minus y squared, but you need to look at this and go, oh, this is x minus y times something. Well, the first 2 things have to multiply together to get what? X squared. The last 2 things have to multiply together to get? But they have to add together when multiplied to a negative. Exactly, x minus y. Exactly. So you try it and, hey, it works. So at this point, what's another way to write something times itself? Squaring it. And 4 is the same thing as what squared? 2 squared. So what do you see at this point? Difference of what? Of squares. So what do we know it factors into? X minus y minus 2 times what? X minus y plus 2. Now are there a few parentheses in there you can just drop? Yeah, you can turn it into x minus y minus 2 times what? Correct. Yes. There's actually a couple ways to factor this one, and you get things that look different. They're equal to the same thing, but it's the same level of factoring. So if you just looked at these two, what do you see? The difference of squares right there. So that's going to factor into x plus y times x minus y minus 4. Can you go any further? No. You can't go any further. Is this a square, right? Is this a square? Yeah. No, it's not. X plus y is not the same thing as x minus y. So this is important for you guys to realize. First of all, you could factor it just like this, and you'd be done. That's fine. Another way to factor it would be to write it like this. Is this the same thing? Sorry, x or minus y squared. Can I reverse the 4 and the y squared?
Sure, why not?
Is this still the same thing as this?
Yep.
Yes. What do you see right here, Kelly? X squared minus 4. What is that? That's the difference of? So it's x plus 2 times? Yeah. These two are the same answer, written differently. Stop. You can't go any further. Yes, it's slightly frustrating. Hannah, put your bag down. Class is not over. I know. There's a little window and your friends are out there. Resist. On 59 here, you just have to test. You just have to test. Did anybody find it?
Yeah.
What does it come out to be? 7a plus 4b. 3. I think it's that right there. I think that's it. Yeah, that's it. No, it's that one. It's that one. Okay, your homework is to do the corrections you need to do and make sure you do the homework that's listed in your syllabus.